Good morning. Today we are going to study another concept called as electric dipole. Electric dipole means an assembly or a system of two charges. Di means two and pole means charges. So electric dipole is a system of two equal and opposite charges separated by a small distance. Let us see the diagram of electric dipole. Now here you can see that plus q charge and minus q charge are separated by a small distance. That distance is denoted by this 2a. 2a, this is taken for convenience because mostly we take the distance from the center of the dipole. So when you take from the center of the dipole to any other point, then this becomes a convenient figure that it will be a here and A here. So therefore the distance between the dipole is considered as 2A. Now examples of electric dipole are HCl, H2O, CO2. So such molecules, they are the naturally occurring electric dipoles. That is, they have equal positive and negative charge. Positive charge can be say of 10 microcoulomb, then the negative charge will be of minus 10 microcoulomb. So plus 10 and minus 10. So equal but having opposite signs. Such a system is called as a dipole. So now in case of dipoles also we have to study the concept of electric dipole moment. Electric dipole moment is denoted by the symbol P. Electric dipole moment is given by the product of charge and the distance between the charges. Here I have drawn P as a vector and 2A also as a vector and charge Q is a scalar. Now you can see that in this case you can take the product of either charge because the charges are of equal magnitude, say plus 10 and minus 10. So the magnitude only we have to consider here. So it becomes the product of either charge and the distance between them. Now this 2A vector, this vector is taken from minus charge to plus charge. It is taken as a convention. It is a convention to take the direction of dipole moment vector, that is 2A vector, from minus q charge to plus q charge. So the dipole moment, it is a vector quantity. It is given by the product of charge and separation between the charges. It is given by the formula P is equal to Q into 2A, and so the unit of electric dipole moment is coulomb into meter, and it is a vector quantity. Electric dipole moment is a vector quantity. Now we are going to study an expression for electric field on axial line of an electric dipole. Let us see here electric field intensity on axial line of dipole. Here you can see that minus q charge is placed at point A and plus q charge is placed at point B. The distance between the charges plus q and minus q is 2A. O is the center of the dipole. Now we have to find electric field intensity on the axial line. Axial line means nothing but the axis of the dipole, that is along the straight line. If this is the x-axis, then we have to consider the point somewhere here. At this point we are interested in finding the electric field intensity due to these two charges. Now since electric field is a vector quantity, we have to consider the vector addition for the electric field due to minus q charge at point P and plus q charge at point P. So you must be remembering the concept of the test charge. we have to place the test charge at the point where we are finding the electric field. So we have to consider a test charge to be placed at point P. So we place a charge Q0 at point P. Now here, due to this charge minus Q, the electric field will be there. So this charge is plus, this is minus. So EA is in this direction. Electric field due to point A. Then this charge is plus, and again we have considered this as a plus charge, unit positive charge or test charge. At this test charge we have to consider the force on this charge. So due to this charge, so therefore it will be having a force. The force will be there in this direction. Now here, this is the electric field due to B, the point B, so we write it as EB. We have to find the net electric field at point B. So for that, we have to write the expression for EA and EB. So as we have studied, the formula for electric field is E is equal to K into Q upon R square. So here we have to find out what is the value of R from the given charge minus Q to point P. So let us consider the distance as, consider the distance from the center as R. Now this distance is A, this is A, and the point from the center of the dipole to the given point, the distance is R. Now the remaining part of derivation is some mathematical calculations here. Just I'll explain you how it is done. At point P, when you consider a unit positive charge, we get EA in this direction and EB in this direction. Now here the expression for EA is written as KQ upon R plus A whole square along PA, and EB KQ upon R minus A whole square along PX. Now R is this distance, and since we have to consider the distance from B, we have to take R minus A. So from this point to this point, the distance will be R minus A. That is why we have taken here R minus A. And since this is a positive charge, the distance of this is R minus A whole square, and the direction of this positive charge due to this positive charge will be here. So therefore along PX will be the direction of electric field EB. Now you can see the denominator of EB is smaller, so therefore EB is greater than EA. EB is greater than EA. So we take E is equal to EB minus EA and work out a few steps. Here we take the LCM as R square minus A square the whole square. When you simplify this further, you can cancel out a few terms, and we reach to this final expression 1 upon 4 pi epsilon naught, that is the value of K. Then this is 4A. 4A is written as 2P into 2A. So this becomes Q into 2A, that is written as P, and R. So 1 upon 4 pi epsilon naught 2PR upon R square minus A square the whole square. This is the final expression for electric field on the axial line of dipole. Once you write down the steps, you will be able to understand it in a better way.